Hello world, welcome. Hello, hello, guten Abend. So, welcome. So we're here again. I looked at this problem briefly yesterday, and as always, I went to sleep thinking about it, and I realized some things, and I have an idea, and I think, I think this problem's a lot easier than I thought initially. I was going to try something kind of wild, kind of all over the place that involved hash maps and memoization and recursion and all kinds of stuff. And it occurred to me that actually all of that's, I think, unnecessary because you can kind of prove something here with this problem, and I'll show you that shortly. What I mean by proof. What it is I'm on about over here. What it is that I'm on about. So, the issue is if you have some n, let's go to 10, let's just, and any k, it doesn't matter which one you pick, this will work for all of them, the same issue. So any position that you can put, let's say, let's do 10 and 5. So let's actually copy this. So we have a copy available. So the issue is that if you start from the left side, you notice the only spot that you can go is 1 to 6. And then you take a look, okay, say, now you can kind of recurse, or take the next step and look at 2 and say, well, if 2 also can only go to 7, right? It can't go to 6, and it can't go left. It has to go to 7. So same thing for 3, right? There's nowhere for 3 to go. Excuse me, to the left side. And 4 has got to go to 9, right? 5 has got to go to 10. And let's even consider. And what does that mean? That means that these values 6, 7, 8, 9, 10 have to go over here. And now there is something kind of interesting. Let's do it this way. Let's do 12. All right. Let's do it this way. So I actually, now that I'm walking through it, I'm starting to see something different. My thinking was that, well, 4, oh, actually, no, yeah, I was wrong. I am wrong. I was thinking there's only one possibility. I thought it was unique, but 4 can go into 2 different spots now. 4 can go to 1, but here's the problem, actually. Here's the issue. Nothing else can go into this position other than 4. That's the problem. That's what I noticed, what I realized. Yeah, that's actually true in both cases. That the only thing that can go to 1 is 6. Same thing. The only thing that can go to 2 is 7. Only thing that can go to 8 is 5 is 3. Or yeah, only thing that can go to 3 is 8. Only thing that can go to 9 is only thing that can go to 4 is 9. And the only thing that can go to 5 is 10. So effectively you end up with the swapping. And what ends up happening is you have the same problem here. The only thing that can go to 1 is the 4. Right? None of these other ones can go that far. Same thing, 5 has to go to 6, 2, 6 has to go to 3. Which then implies that you have a subcase with n minus k, right? or n minus 2k, and k equals 3, right? So basically you have sort of an inductive proof that this is the only possibility every single time. And this implies that n's got to be divisible by 2k, right? N has to be divisible by 2k, and n has to be divisible by 2k, and what else? There's only one unique solution, which also is going to end up being the lexicographically smallest permutation. So that's kind of interesting. I don't know. So that's what threw me off, though, is that I think it's true what I just showed, but it would mean that the lexicographically smallest is it's because it's unique. There's only one such permutation, that this has got to be the only one. Now, I'm not sure about this, though. I'm like kind of conflicted, because no, it's true, right? Because the only thing that can go to 1 is 4, and the only thing that place that 1 can go is to 4. So you've got to swap 1 and 4, and that means implies you have to swap 2 and 5 and 3 and 6 all the way across. Yeah, and then right, that's it. That's actually just it. Yeah. So anyway, kind of cool. So now let's go ahead and solve this then. So basically, what this looks like is for each. So actually, I'm wondering. I mean, this could just be one function. This whole thing. This is not. Really don't need any variables in here, I think. Unless I'm mistaken, something you can do this sort of in one shot. So if modulo n and 2 times k is equal to 0, right? If that's the case, continue, otherwise return -1. And the continuing is you're going to take, you have an into a vector, and you're going to say cons over a range, and you want a certain function. So anonymous function, we'll take this, uses anonymous function. And we're going to have this range is, let's say, 0 to I want to say modulo n 2 times k, or just, yeah, I think that's right. So basically what you're going to do is you're going to loop from 0 to, like, you're going to divide, not modulo, it's division, simple division, range over this. And I think also you have to convert this to an integer because it's a division. So you divide by 2k to get the number of pieces you're going to chop it up into, and then you're going to range over those. For each piece, you're going to create each of these components, which is just swapped 4, 5, 6, 1, 2, 3, which looks like you're going to cons 2 different ranges together, conjoin 2 different ranges. One of them is going to be range from, now this, actually we probably should range from 1 to this int -1. Yeah, let's go, yeah, let's do it that way. 1, and then this is just decrement, or increment rather. Yeah, because we want to do 1 index this whole thing. Yeah, 1 indexed. So, actually, I don't want to do that. I think everything is just incremented by a bit. Maybe, no, because this has got to get multiplied by, I don't know, I can't do it this way, I gotta keep it 0, I think. These ranges though, the range that comes first is gonna be 4 when this is 0, so it's gonna be 4, so, you know, I'm gonna add to this number k, which would be 3, and you're gonna add a 1 as well. And this is gonna go from, we can do this as well. Yeah, so it'll be 3, this will be 3, 4, 5, and then all those incremented by 1. 3, starting at 3, and then ending at the increment of percent and 2 times k. No, see, that's the problem, actually. It's actually multiplied by k plus k. Yeah, that's a little awkward. That is a little awkward, I will admit that. This function, what does it look like? It's 2 ranges. We're conjugating here, conjoining. I don't know what I'm doing here. I mean, I know what I'm doing, but I'm like, this is way messier than I was expecting it to be. But okay, if it was 0 indexed, it would be add. It's k plus 1. No. Multiplied by k. So multiplied by 3. Where this is 0, 1, 2. This would be 3, 4, 5. So it would be the first range is multiplied by k and then increment over the same thing plus k. Yeah, I think I understand. So yeah, so multiply by k and then increment by 1, right? And then this one, you also add k plus k, which multiplying by k and then adding k is equivalent to adding 1 first and then multiplying by k, but we're not going to do that. We'll just multiply by k and then add k and then increment. And then this other ending part of the range, I think it's exclusive range. Excuse me. Exclusive, yeah, so I actually increment this twice. Nice. So we'll multiply by k. It's actually going to be k plus 1, right? Also add k, and then, yeah. So that's this range. Okay. Conjoin. Now, there's two elements here, right? You're going to conjoin this with this guy. And you're going to conjoin the result of this with another conj here. This is the first. This is the first. What do they call that? Argument to the next conjoin, which is then another conjoined range of. No. These are the two ranges. Oh, it's so confusing. Because these are the arguments to the range. So I need two ranges. And then this conjoin is going to have another range that we conjoin with. Yeah. How's that for confusing? Which then this range has two values in it as well. Oh no, and oh no, oh my goodness. This into is the, oh man. Hold on. This range actually is the into. I see. Yeah. This is the anonymous function that we're using to build this here, and then we're looping over all these pieces, these integers. But now we've got these two ranges. This one has to start first, so this is going to be multiplied by k, and then add k. Now this range, you're going to multiply by k, but you're not going to add k. That's the bit. You do increment still anyway, though. And here, now the interesting part is actually you multiply by k plus 1 here. Yeah, same thing, multiply by k plus 1. Don't have to add k again though. And then you increment twice. Yep. Okay. Kind of involved here. But then what you do is you take this whole thing and you say Clojure dot string join and throw that in there. And that ought to do it. Could even conj range and have these two okay, good. Seems like kind of a lot, but I think it does the trick. Let's see how that goes. See how that goes. Not sure how I feel about functional programming after all. Arity number of args passed. You're kidding. Which one? One, pass to absolute permutation, compiling, 28.1. One of these only got one argument, I guess. It should get 2 arguments. Let's get 2 arguments though, no? Oh. Is this a reduce that we want? Maybe that's why. Maybe that's the issue. Yeah, it could be the problem. Yeah, confused into with reduce. Yeah, I think that's the problem. Yeah, to X form from. That wasn't really an X form that we were using. Divide by 0. Are you kidding? This is a joke. Your output 2, 1. I think we just use an into. Here. What? Come on, man. How does that not? These sequences don't work the way I thought they worked. What? What? I mean, it doesn't really matter if it's just a sequence. It doesn't make a difference really. All right, we're having some issues here. I want to try into. See how this goes. There's an X form in between. Nah, it's not really. I think reduce is what we need. Use this function, reduce, use this thing we're going to reduce into. We're going to conjoin this piece, which is now this. Yeah, so it looks like we have this function here. We can join this with this range and we get something, and then we can join this result with this range and we get something, and then that's it. Actually, we'll return the result of that. So that should do what we want, although this ranging divide by 0, huh? K is 0. I guess if K is 0, then K is 0 and mod 0. Huh. Right. Assume. Maybe I should make a anonymous function here for that. Oh. Okay. Alright, so we got this helper. Which has some n and k, and we'll say if and not equal to. It just occurred to me I could have done it this way. That's okay. Okay. How does that work? Lift my hands to you. Lift my hands to you. Arguing with Dad says that's not Christ-like. Arguing with Dad saying that's not Christ-like. How do I do a not though? Not equal. Not equal. Okay. I like using that. Not equal. Lift my hands to you. I think, no, if it is not, no, hold on. I think it's incorrect. Helper in this context. What do you mean? No. Lift my hands to you. I'll lift my hands. I should probably look at the words, check out the words if I'm going to be singing this song. Don't even know the words. Hallelujah, hallelujah. Dad is sleeping here. I don't want to be talking too loudly. So it's 3-0, right? So 0 should just be 1, 2, 3. So it shouldn't actually return. Okay, so it was correct to have this helper. So we say if, so we should start with if k is 0, then we should return something that looks like this. Hallelujah, 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 hallelujah. Not really sure about this here. Doesn't want to make an I sequence out of. Like this, actually this should be, you should map a string to this. Oh, that's probably, okay. Yeah, never mind, we could probably get rid of that. That might be why. That might have something to do with the issue that we're seeing. Hallelujah, 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 hallelujah. Don't know how to make a sequence out of a long. What? Where is that happening? Which line? 38. Excuse me. What is going on? What is going on, man? Hallelujah. Hallelujah. Alright, it's not clear to me at all where this is executing, which line this is. It's kind of frustrating. Don't know how to create I sequence from Java language long, compiling 38.1. Compiling solution 38.1. Can't make a sequence from language long. What do you mean? What do you mean? What do you mean? What do you mean? I'm very confused. I don't know where the error is occurring, you know? I could comment things out, but that's kind of ridiculous. Clearly it's the helper that's causing the issue, right? Otherwise you could just... It's gotta be. Oh. Something else is going on here. Something else more interesting is going on here. Uh-huh. Oh. Or maybe it's the compiling of this function. It's actually a compilation error? Really? Hallelujah. Hallelujah. Oh. So something else very odd is happening here. Something strange in the neighborhood. Ghostbusters. I'm very confused. Okay. So this is okay for a while, and then string join result. Oh, that's why. Got it. Okay. So there's a, alright, I understand. That's the problem. It's because of, okay. Alright. This is like, okay, I guess. Wow. Whoa. Wow. Wow. There we go. Alright, now I see what the problem was. Jeez, man. Talk about hard to track down. Because the join is already, oh my goodness, man. Because there's already a join that occurs. Now what is this? This 2-1. So, oh, I think I see the problem. There's a conjoin of the range. That's the issue. No. We don't want this sequence. We want, actually, it's going to be apply conjoin, which is really awkward. Like, it's going to be more like apply partial conjoin like this. And then similarly here, apply partial conjoin. I hope this works. And actually take the result of this thing. I don't know. The result of this. As strange as that's gonna look. Yeah. I hope that works correctly as well. Yeah, dude, this is so much slower than how I would do things in Python. Oh man. -1. Because it's okay. Alright, come on. Really? Because it does a conjoin over this string. This, you gotta be kidding me, man. How? What is that even? What is that even? Iterates over this. That's pretty funny. How do you even begin with that? What do you even do? What do you even do? Hallelujah, 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 hallelujah. I don't even know, man. I don't even know. I don't even know. We could just go ahead and ditch this part. This is kind of ridiculous. And yeah, just throw that in there, and then also Clojure join over these. Hallelujah, 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 hallelujah. So what happened here? 6, 7, 8, 9, 10. 1, 2, 3, 4, 5. This is what I expected, but I didn't get it. These two cases. 10 and 5, 10 and 5. What happened here? Well, it looks like my theory is correct, but the implementation is not. Hallelujah, 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 hallelujah. I think this is what I did wrong. Maybe I didn't. This is okay. Applying. this partial. And right, this partial. And actually, it's this thing is the argument. Yeah, it's gonna look kind of funky. I don't know, man. It's not that concise. This is like kind of wonky. This whole thing. Come on, man. What's going on? Why do we get 6? It just stops there. What is going on? I don't understand. Still wrong. What is happening? What the heck is happening? Come on. Come on. I don't know. What do I even do here? This is frustrating. Alright, let's just print these things. This is what I expect at least. Okay, let's print this. Why are we getting just 6-1? Why that though? Of all the things. 0, 0, 0, 0. No. Well, that kind of helps, I guess. What? What? You kidding? The thing with them doing things imperatively is that you can kind of test by. Oh. I mean, okay. 1, 2, 3, 4. Excuse me. Oh no. Yeah, no, that's fine. That's actually what we expect with the 10 and the 5. These are the 4 times. It's 10 and 5. 1, 2, 3, 4 times. Actually, yeah, we should have a 0 in all 4 times, all 4 cases. Never mind, that's working correctly. Okay, take that back. What I'm missing here is okay. Alright, so this is what we expect, as it turns out. Okay, how about these other ranges? Ah, come on, man. It's all connected. It's all like, how are you supposed to like, isolate one piece from the other? That doesn't jive, man. How? So this is just a 0. It's not. Okay, reduce. So process 0, and we end up with this function. Apply this partial function. How does this work? Wait, what are we doing here? Oh, right. The into takes 2 values from and to. So maybe that's why. To and from. Alright. So yeah, we take 2 from. This is partial conj of our initial. Oh, that's why. Mutability. Got it. Yeah, of course. Can I do this though? Does that work? Please tell me that works. I don't think that works. That's not gonna work. I think this is also gotta be an into. Dang it. Dang it. Raise my hands to you. What? Ah! What? What? I think I know why. Thinking. I think I know why. And I think I know why. Alright, so this is 0. So 0 times this. No, k is 0, so. No, this is 0 initially. And k is whatever. 3, 5. 5. So this is 0, 5. From 6 to. Yeah, that's the problem. No. You're not incrementing this k. It's the same thing, except with another k at the end here. That's why I just did the math wrong. Same thing over here. Instead of increment k, you have raise my hands to you. You add k. I'll raise my hands to you, Lord. Okay, how do we do? Why do you build me a buttercup? Don't break my heart. Oh, come on. Inliner. So actually, I think I need to go. Well, what? Wrong number of arguments to. Oh. Yeah. What do you build me a buttercup? Don't break my heart. 2, 3, 1, 2. Nice. Something's not right there. No, dude. No. this is starting point is I times k plus k, because we're shifted over to the right, and the ending is going to be I plus k, I times k plus 2k. K is 1. This is 1 to 2. Wait a minute, what am I doing wrong here? Something's wrong here. Excuse me. I think we don't increment this second time. That might be the problem. And now this here is increment by 1, I think, yeah, okay. And then this is, you add 1k here, and you don't increment again. This doesn't seem right. Something doesn't seem right here, I don't know. I don't know, man, my brain's starting to hurt. I think trying to get these ranges correct without printing them out. Oh, that's right. Nice. Of course. See how we did. How I took off. Oh, nice. Lots of okay. Lots of failed test cases. Okay, that's good. Oh, all of them. All right. Fantastic. What happened? What happened? What do you mean? What do you build me a buttercup? Don't break my heart. Okay. Right. I think we have to take this locally. Find out what was wrong. I don't know, man. Well, I didn't really test anything beyond like 2 iterations of this. Right, like I didn't test if this was more than 1, this division. Alright, let's do, I don't know, let's grab one of these. Doesn't really matter. Let's try this. 28288. I have to figure out which one of these is wrong though. I don't know. Let's try some simple test cases first to find out what's wrong. These I think should be kind of obvious what's wrong. Well, actually, let's just see. Yeah, okay. Alright. Okay, that's correct. Oh, that's wrong. Oh, there's multiple 2s? My output. Oh. What? Excuse me? Why did I get... Come on, man. Oh, no. That's not good. Of course. 3412 5634. Nice. It's kind of a rookie move here. Kind of rookie mistake. Yeah, I don't know, man. I'm not with it here. It's just like super simple but just cannot seem to do it properly. Clojure. My own fault, but still stings. So this range is, yeah, no, this is supposed to be increment k, I think. I think I was right the first time around with this idea. So you have this range. So this one is a little further ahead. We'll come back to that in a second, but this range should just be k times what you're looking at, right, this index, and then you just add 1 because we're 1 indexed. And this portion is going to be, it's going to go from, so if it was like 5 and k was 3, it'd be from 15 to, which would end up being 16. If k was 0 or 3, right, it would be 0, we have 1 through 3. If k is 1, it'd be 4 through 7, 4, 5, 6, 4 through 6. 1, 2, 3, 4, 5, 6. Yeah. So it's k elements. The size of this range is k elements in size, which means the difference between this value and this value is exactly k. Is that right? I think k plus 1. 5 minus 0 plus 1 means there's 6 elements total. So if you take this, right, you subtract these two parts, you end up with k. And I think this is supposed to be a little bit bigger. The ones that come first, 2, 1, 4, 3. No, 2, 1, 6, 5. Oh my goodness, man. This hurts my brain. K is 1. No, not k. K is 3. Sequence of value is 0. Then you have range of 1 to, we want to have 4, right? 3 plus 1. So you have this extra increment also for, so you actually have 2 extra increments, right? One because it's exclusive and the other one because it's is 1 indexed. So we'd have 1 to 4, which is exactly k times 3, or rather, yeah, well, let's increment this thing, really is what it is. Right, 1 more extra k here. And then you're not really adding any more k's after that. I think you just add 2 values. I think that's what you need. I think that's it. And what do you get if you do this? It's probably something similar on the other side as well. Two, 1, 2 should be a 4 here. Okay. What even is this? 1? Come on, man. K is a 1. This gets. Come on, man. Basically a 2, 1. Everything just swaps with the 1 next to it. What you're gonna want is 2, 1, 4, 3. So when k is 1, this should just always be just one number, one value. So you get, maybe you're not supposed to have this extra increment here. So this is, so 0, right? So this becomes 1. And then this is 1, no, k times 1, which is 1, incremented twice. This becomes, k becomes 1. This is 3. This becomes 1 to 3. So this becomes a range of 1 to 2. It's not what we want. Oh, it's killing me, man. It's killing me. This is what we want. No, these numbers need to be incremented by 1 as well. No. What? What is going on? These all need to be, oh my goodness, man. This is terrible. What a freaking, how do I even, I don't know. Oh. I get this feeling like this is way easier if I do it imperatively. Why do I feel like that? I think I need to just write it down. Yeah, I need to write it down. So, index 0, index 1, you've got, right, these two cases. This is 0 times k plus 1, 1, and then 2, 3 is going to be 1 times k, which is 3, no, well really just plus k, right, 0 times k plus 1 plus k, which is just 1k plus 1, which is 1 plus 3, which is 4. But this is, yeah, well this is correct, right, because this is exclusive. So you just add 0 times k plus 1. Or increment this guy that you're multiplying by k. Increment the, yeah, that's fine. What's the issue? All right. Yeah, it's okay. Then, so this is the second, this comes second. And then you have both of these plus k, right? No, plus 2k. That's what I'm missing. It's plus 2k now. That's what I'm missing. It's exactly the same thing twice, but just plus 2k over on this side. Okay. Yeah, I kind of needed to like do the math. Exactly the same thing, right? So this guy goes here, but now it's going to be plus 2k, plus 2 here. And then over here, same deal, or a similar thing. And then instead of plus 1, it's going to be plus 3. There we go. Oh, finally. Oh my goodness. Jeez. Unbelievable. Oh no, it's still wrong. Oh no, come on, man. What did I do? What? What do you mean? These are all, I think, up by... Oh no. What is going on? This is so wrong. What is even going on? What is even going on? So these are right, but then these are wrong. And then these are totally wrong. What happened? What? What is happening? Hello? Excuse me? What? What? I'm just utterly confused, man. I don't know. I don't know what's going on anymore. So this should be 2 times k plus 1, and then 3 times k plus 1. This would give you 7 to 10. Oh. That's way off, huh? What is even k in this instance? K is the number of elements. Okay, well that makes sense then. Number of elements in this this range, these ranges. 2k would give you 7, and this k plus 1 just gives you 4 again. Interesting. Oh yeah, no, that's correct. All right. No, never mind. Never mind. I'm math good. I'm math good. Oh my goodness, man. It's depressing. That's wrong. That's what he does wrong. Okay. I don't know. I don't know what to say. I have no excuse. Just gotta do the math. That's all. It's still wrong. This is crazy, man. Why is this so difficult? So all of these need to be up by 1. These need to be up by 2. These need to be up by 3. And these need to be up by 4. What the heck is going on, man? What the heck is going on? Now you multiply all this by 1. This whole thing should be shifted to the right 2k elements. Thinking maybe this is supposed to be multiplied by... Maybe this is supposed to just be... How do you do this? 1 to k plus 1 exclusive, and then k plus 1 to 2k plus 1 exclusive, right? And then each of these values should be incremented by call it alpha. plus 2k alpha where alpha is 0. Maybe that's the missing piece. Because now when alpha's 1, all of this gets shifted to the right by 2k. I guess you would think this is really simple, but I am struggling with this. Yeah, I think that's right. Let's do it that way. 1 to k plus 1. And that's 2k plus 1. And all of this is plus this extra alpha term, which is 2k alpha. I think it's a lot easier to understand. And hopefully actually correct. Hopefully actually correct. Yeah. 1 to k plus 1 plus 2k alpha. Okay. Alright, let's see how this goes now. Oh, no. There we go. Alright, let's see how that goes now. Let's see how that goes now. Alrighty, I think I finally got it. Let's see how we do. I don't know. I don't know if we got it. We got something. Okay. Holy smokes. Oh my goodness. Jeez Louise. Oh, what a tragedy. So this is amazing. So this has nothing to do with Clojure, by the way. This whole thing. It's like, yeah, this had nothing to do with Clojure. I would have done the same thing in any other language. I don't know, man. I don't even know anymore. Okay, I think I'm just gonna stream here. It's like, right. So yeah, basically, I mean, it was really simple what it does, right? It just permutes these given k. If n is divisible by 2k, then you permute these blocks of 2k all the way across. For some reason, I couldn't like math it out, like how to actually get these swapped blocks. And I believe you can prove, I think I showed it earlier, there's an inductive argument to show that these blocks are, what do you call that? They are, oh wow, just killed that bug. You can use an inductive argument to show that this is if there is such a solution, then it's the unique this is the unique solution. There's no other possible solution. So when they say find the lexicographically smallest, it's kind of just a red herring, kind of a distraction. So yeah, that's how you could solve this in Clojure, functional programming, using functional programming. But I don't know if this is really idiomatic. I mean, I don't know. Kind of would like to see other folks sort of Clojure, sort of other functional programmers code. But there you go. That took so much time. My own fault though. I definitely could have thought this through a little bit more about just shifting over. I had the right idea, but the math just in my mind wasn't right. I don't know. I like how I would have gotten that right the first time around. I don't know. I want to say more practice, but like, yeah, I guess when you're defining ranges, being a little more careful. Exactly, defining things that like iterate over ranges. I don't do that too often, I think. That might be why. I don't know. I don't exactly know. Anyway, yeah, so that's that problem. That's the 10th problem. I kind of feel like I still need more practice after all, but at least I think I need more practice in Clojure if I'm going to be. I don't know. I think even if I did that in Python, I would have ran into some issues. Debating whether I really need more practice or not. Probably not, but I guess it couldn't hurt. So I'll do a little bit more, but not much. I think what I'm going to start doing now is move on to the next set of things to work on. I wanted to just do 10 problems with this language. And I think the next thing is, for me, probably start interviewing. Get, interviews set up. Start interviewing for various positions. See how that goes. And, yeah, work on that, do that. That's moving forward, one foot in front of the other. Gotta move forward. Yeah, I wanted to build a website, but I can do that, I guess, in Clojure. I wanted to use Clojure for the back end and Clojure script for the front end. I'm starting to think that I'll use Clojure script for the front end, and then maybe something like OCaml for the back end. That would be kind of neat to use. OCaml's kind of quick in the functional programming language. Get familiar with those things, build a small website for myself, and probably, I don't know, make videos in between about like building the website, and it's kind of there's all kinds of stuff to make videos on. But yeah, I think interviewing might be the right thing to do though, first. And I'll work on that next then. Put down Clojure script for a while. So yeah, thank you again for watching. Talk to you all soon. Have a good rest of your day. Take care.